Now let's work through some examples, and then when we're done with the examples, I'll give you the general rules. So we've got a limit problem here. We've got x is approaching -2, so that's going to be easier to work with. And we've got this function here. Notice that I could rewrite this function as f of x is equal to x squared, g of x is equal to 5x, and then I would have f of x plus g of x, and I'm finding the limit of the whole thing. And so I write that out for you so that you can see the general rule a little bit later. Now, how am I going to solve this? Well, I can just plug -2 into this expression. So as this combined function gets close, where x gets close to -2, we're just going to have -2 squared plus 5 times -2. We're going to get 4 minus 10. And as x is getting close to -2, this function is going to be close to -6. And notice we're not dividing by 0. Not dividing by 0, or nothing is undefined in this problem. So taking the limit is straightforward. In fact, just like how do we find the limit? Well, we could just plug in -2 into the function and evaluate it. Let's try a harder problem. So we want to find the limit of this function. What kind of expression do we have here? Well, we have a radical expression, and we want to find the limit when h approaches 0. Now, if I do that, I could rewrite this as 0 plus 1, -1, divided by 0, and you can see I get something very bad in mathematics. We don't want undefined expressions. 0 divided by 0, no idea what that is, what that means. Doesn't seem to make a lot of sense. How can we take nothing and divide it by nothing? So that's not very satisfactory. So we're going to have to do a little bit of manipulation of this expression if we want to find its limit as h approaches 0. So let's take a closer look at the numerator. We've got something like a minus b. And I know that if I multiplied it by a plus b, I get a squared minus b squared. So why don't we try this? I'll keep my limit here, just so you know. We haven't done anything yet. I've got h plus 1, -1, and that whole thing divided by h. What happens if I multiply the numerator and denominator by the square root of h plus 1, and then the whole thing plus 1? I'm going to get square root of h plus 1. Well, maybe I'll try and write this not quite that large. And so since I've done the same thing to the numerator and the denominator, I haven't broken any rules. And the numerator is going to become, well, the square root of h plus 1 squared. That's just h plus 1. minus 1 divided by h square root of h plus 1 I'm going to simplify this, so now I've got h over h square root of h plus 1. Our h divided by h is just equal to 1, and so we get 1 over the square root of h plus 1. Now if I take the limit as h approaches 0, I get 1 over square root of 0 plus 1 is equal to 1. So that's one way to solve, or I should say, to be able to take the limit when we have an expression that's undefined at the limit. And we can see that as h gets very, very close to 0, this expression is going to be equal to 1. Now, our two previous examples were illustrations of rules 1 and rules 3. And we can see with these rules, these are pretty well behaved. These are well-behaved rules. If I want to know the limit of two functions summed together, it's going to be equal to the sum of the limits. And we can perform these operations before we take the limit, looking at the left-hand side. And looking at the right-hand side, performing what's in the bracket here and then taking the limit, that would just be like taking the limit of f of x plus the limit of g of x. And so I'm not sure, you really are going to need these rules, at least certainly not in this course. You're not really going to do we're not going to do a lot of advanced manipulation using limits in this very abstract conceptual framework that these rules would help us with. But you could see it, especially in an econometrics class, maybe upper year economics. It could certainly come up, and graduate school, you might see things like this. Now, to end this video, why don't you try this problem? So I'll help you just make sure to get you started a little bit or explain the problem to you. You've got a function here, f of x, and it's equal to x squared plus 2x. So x is kind of the placeholder here. Now, the question is asking you to find the limit of this thing here. And so you're going to use your definition for f of x and f of x when x is equal to a. You're going to plug it into that expression and find the limit. So I suggest you press pause on the video, try this problem yourself. I'm going to solve it for you, so hopefully you've already got an answer in front of you, and you can check your results. So to get started here, I'm going to rewrite this thing using this. So we've got it in some sense here. We've got two equations, and so I've got x. Oh, let me write out the limit. I've got x squared plus 2x minus a squared, right? A, I'm going to, wherever there's an x, I'm going to put an a, minus 2a. And that whole thing is divided by x minus a. I can do a little bit of rearranging here. So I've got x squared minus a squared plus 2x minus 2a for x minus a. And I'll keep my limit here. I don't want to forget that I have not taken the limit. Remind me what I'm doing. And I can simplify the numerator quite a bit. So notice here that we've got a difference of squares. Got a difference of squares there. And so I can write this as x minus a, x plus a, plus 2 x minus a divided by x minus a. If I want to make this really clear, I could write x minus a, x plus a plus 2 over x minus a. Write my limit again. And we've got x plus a plus 2. Now I'm going to take the limit as x approaches a. So wherever there's an x, I'm going to put in an a. And so I've got x plus 2, x plus x, that's like 1x plus 1x. If I want to factor out the 2, I can factor out the 2. And I'm left with 2 times x plus 1.